Okay, so today we're going to be learning about limits. And I found limits quite fascinating because this was one of the things I first encountered in a book called Essential Math for Data Science, where the notation looked quite complicated. So I felt very smart, but it was actually very, very simple. So you can impress your friends, your teachers, your friends and family, whatever you want, with this notation and explain to them exactly what limits are because it is very easy. So let's take a look at this example, right? So let's just say we have a function which is f of x is equal to 1 over x. This is quite a simple function, and I think intuitively you can understand that no matter what our x value is, the output is never ever going to be equal to 0. So how do we describe this mathematically using notation, right? This is where limits come into play. So we would describe it like so. We would write down limit as x approaches with an arrow, as x approaches infinity, 1 over x gets close to, but is never 0. Now I know this seems quite counterintuitive because we've just used a equals here, but this does not mean equals. It just says gets close to, but doesn't equal 0. Okay, that's what this entire thing means. So we can read this as x gets larger and larger and approaches infinity, 1 over x gets closer and closer, but never approaches 0. What does this look like on a graph? You probably can already imagine what it might look like on a graph, but let's just say we have the y-axis and the x-axis, and we go up to 10 and 10 here. 1 over x on this graph would look something like this, where the gap between this point here and this point here gets narrower and narrower, but never actually hits the axis boundary. Okay, and this would work the same way for negative values too, by the way. It would just be in a different direction. So you could use negative values if you wanted to. We're not going to do that today, but you could if you wanted to. Okay, so what else should we know? Well, let's take a look at something a little bit more complicated. And this time we're going to use, instead of x as our input variable, we're going to be using n. So what does that look like? Okay, let's say we have a limit, which is as n approaches infinity, this equation is equal to e, or rather approaches e, but is never quite e. Okay. So how do we know this is true, or why is this important? Okay, well, e is a mathematical constant, and this is used in many applications, such as calculating population growth. We use it to calculate decay. We use it to calculate interest. That's what we can use e for. And the interesting thing about e is if you take the derivative of e, which is the rate of change, the derivative of e is itself, which is quite interesting because no other number, well, I don't think any other numbers have that particular property. Okay, if you want to know what e actually is as a numerical value, it is 2.71828 something something something. Okay, this is what the numerical value is. And what's quite interesting about e is if you plug this into a computer program or a programming language like Python and use SymPy, Python will actually recognize that 2.7182 is the mathematical constant e, which stands for Euler's number. And Euler is the one who invented this number or came up with this concept. Python actually recognizes that it's Euler's number, and Python will print out a capital E. And if you're interested in that, you can take a look at the next video where we're going to be exploring how to explore the relationship between limits and how we can program this in SymPy to get a better understanding of what limits are. Because this is quite easy. I think this is quite easy here. We're essentially saying as n approaches infinity, this equation gets closer to e, but is never quite e. Okay, and like I said, this can be quite counterintuitive using this equals here, but this is how we express values that approach a specific number, or values that increase or decrease forever and ever. we use limits. So I hope you find that useful. Next lesson, we'll be looking at a little bit about SymPy and how to explore the relationship using SymPy and Python. And then we'll be looking at derivatives, because this kind of ties into derivatives quite nicely. So I hope you enjoyed this video. Hope it was clear. I'll be trying to do a lot more of these videos in the future. So please subscribe, follow, like, all that good stuff.